Okay, so here we have section 5.2, which deals with inequalities in triangles. So there's our main ideas and vocabulary. No new vocab words this time around. Alright, the first couple slides here are just reminders about what inequalities are. So if any two numbers A and B, A is greater than B only if there's some number that if you add it to B, you can get it up to A. So that's the definition of greater than. Down here, we've got just properties for inequalities. So these properties here. So just say that the addition and subtraction properties work for both greater than and less than signs. Okay, so example 1 here, determine which angle has the greatest measure. So you're given angle 1, angle 2, angle 3, which of the 3 is the largest? Well, the answer is angle 3. The reason is that angle 3 is equal to angle 1 plus angle 2. So it has to be larger than either of the two angles. Which gives you the exterior angle inequality, which states that the exterior angle is greater than either of the two remote interior angles. So, example 2 here, we're going to use that to answer these questions. So, angles that have measures less than angle 8. So there's 8. So 8 is an exterior angle, which means any remote interior angles are less than it. So you have this triangle here, which means that angle 4 and angle 6 are both less than 8, as well as if you look at the big triangle, angle 2 and angle 7. Now even though angle 7 isn't the full angle there, 6 and 7 together make up a single angle, and that angle is remote interior to 8, so it is less than it. So if 6 plus 7 is still less than 8, 7 is also less than 8. And then here measures greater than angle 2. So here's angle 2. Angles greater than that would be remote exterior angles. That would be angle 4, because that's outside this triangle, and angle 8, which is kind of the reverse here. If 2 is less than 8, 8 is more than 2. Alright, here you have theorem 5.9, which just says if one side of a triangle is longer than the other side, then the angle opposite the longer side has the greater measure than the angle opposite the shorter side. So if you know the lengths of the side, so on this triangle, for example, if RQ is the longest side, angle P is the largest angle. And then here we go, example using that. So determine the relationship between measures, so ADB and DBA. Well, ADB is opposite 10 and DBA is opposite 8. So angle ADB is greater than angle DBA. The bottom one here, CDA and CDB, that's CDA, that whole angle, and CBA. Now, it's tempting to just do 10 plus 16 to get 26 there, 8 plus 15 to get 23 there, but you cannot technically do that because this inequality only works for triangles, and this whole shape is not a triangle, it has 4 sides. So what you have to do is break it down. So you have to do CDB compared to CBD. So CDB is more than CBD because D here is opposite 16, B here is opposite 15. So that angle here is bigger than that angle there. And then you do the same thing down here. ADB is more than DBA. We already did that. So if this angle is bigger than that one, and that one's bigger than that one, this total angle is bigger than that total angle. So angle CDA is greater than angle CBA. And then the last one is just the reverse of theorem 5.9. If one angle of a triangle has a greater measure than another angle, then the side opposite the greater angle is longer. So if I know that angle P is bigger than angle Q, I know that RQ is bigger than RP. So, and that's the end of the section.